parallel lines and proportional parts. Theorem 1. If a line is drawn parallel to one side of a triangle and intersects the other two sides, then it divides them into segments whose lengths are proportional. Again, if a line is drawn parallel to one side of a triangle and intersects the other two sides, then it divides them into segments whose lengths are proportional. For example, since DE is parallel to BC, therefore AD over DB equals AE over EC. Example, in the figure opposite, XY is parallel to BC, AX equals 16 centimeters, BX equals 12 centimeters. If AE equals 24 centimeters, find YC, and if YC equals 21 centimeters, then find AC. Again, XY is parallel to BC. Therefore, AX equals 16 and AX equals 16 and BX equals 12. Then, if AY equals 24, then find YC. That's the first required. The second required is if CY is 21, then find AC. The solution: since XY is parallel to BC, therefore, according to the theorem, therefore, AX over XP equals AY over YC. And by substitution, 16 over 12 equals 24 over YC. Therefore, YC equals 12 times 24 over 16. That's equal to 18 centimeters. Since XY is parallel to BC, therefore AB over BX equals AC over CY. Therefore, 16 plus 12, which is AB. Again, if XY is parallel to BC, then therefore AB over BX. Again, AB over BX equals AC over YC. So, AB is 16 plus 12 over BX, which is 12, equals AC, that's the required, over YC, which is 21. So, 28 times 21 over 12. 28 is the summation of 16 plus 12. So, 28 times 21 over 12 equals 49 centimeters square. Corollary: if a straight line is drawn outside the triangle ABC, parallel to one side of the triangle, say BC line segment, intersecting AB straight line and AC straight line at D and E, respectively, as shown in the figures, then AB over DB equals AC over CE. Again, if a straight line is drawn outside the triangle ABC and parallel to one side of the triangle, say BC intersecting AB and AC at D and E respectively, as shown in the two figures, then AB over DB equals AC over CE. As we see in these two figures, BC intersects AB straight line and AC straight line at D and E. Here also it's the same. ABC intersects AD B straight line and AC straight line at D and E. So AB over DB, okay, AB over DB equals AC over EC. The same for this figure. So AD over AB, AD over AB equals AE over AC, and AD over DB equals AE over EC. Similarly in this figure. Example, in the figure opposite, ECE line segment intersects BD line segment at E. These two line segments intersect at E. X belongs to AD line segment. X belongs to AD line segment. Y belongs to AE line segment, where XY is parallel to BC parallel to DE. So these three line segments are parallel. If AB equals 6 centimeters, AC equals 5 centimeters, AE equals 12 centimeters, AE 12 centimeters, and EY equals 4 centimeters. Again, XY is parallel to BC, parallel to DE. If AB equals 6 centimeters, AC 5 centimeters, and AD equals 12 centimeters. AD equals 12 and EY equals 4 centimeters. Find the length of AE and DX. Again, find the length of AE and DX. So, since AED is parallel to BC, therefore AD over AB, they belongs to the same line. AD over AB equals AE over AC. So, by substitution, 12 over 6 equals AE over 5. So, AE equals 10 centimeters. So, the second required, in triangle AED, in this triangle, XY is parallel to DE. Therefore, AE over EY, AE over EY equals AD over DX. So by substitution, AE equals 10, so 10 over 4 equals 12 over DX. Crossing multiplication, so dx equals 4.8 centimeters. Converse of theorem 1. If a line intersects two sides of a triangle and divides them into segments whose lengths are proportional, then it is parallel to the third side of the triangle. Again, if a line intersects two sides of a triangle, this line is this purple line, which is DE, intersects two sides of triangle, which is AB in this figure and the second figure and in the third figure. The line he talk about is DE in these three figures. So, if a line which is DE intersects two sides of triangle, these two sides are AB and AC, and divides them into segments whose lengths are proportional, then it is parallel to the third triangle, to the third side of the triangle. That means that AD over DB, AD over DB equals AE over EC. Therefore, DE is parallel to BC. Similarly, in the second figure, AD over DB equals AE over EC. So the two lines are parallel. Finally, AD over DB equals AE over EC, all the line. Therefore, these two lines are parallel. Another example. In the figure opposite, ABC is right angle triangle at A. Right angle triangle at A. Prove that ED is parallel to BC. Then find the length of BC. So the solution is, since triangle ADE is right angle triangle at ADE, right angle triangle at A. So as you see, AE equals 4 centimeters and DE equals 5 centimeters. So we can get the length of AD by Pythagoras. Using Pythagoras, AD equals the square root of 5 per 2 minus 4 per 2. So it will be 25 minus 16 equals 3 centimeters. So we can get the length of AD. So by using the ratio, AD over DB equals 3 over 6 equals 1 over 2. And AE over EC equals 4 over 8 equals 1 over 2. So the ratios are proportion. AD over DB equals AE over EC. So therefore, ED is parallel to BC. That's the first required. So since they are parallel, so the two triangles are similar. From the parallelism, we get that the two triangles ADE and ABC are similar. From similarity, we can get that AD over AB equals DE over BC. Equals what? Equals 1 over 3. So, by substitution, 5 over BC equals 1 over 3. So, cross multiplication, BC equals 15 centimeters. Talis theorem. Theorem 2 said that given several coplanar parallel lines and two transversals, then the lengths of the corresponding segments on the transversals are proportional. Again, given several coplanar parallel lines, he means L1, L2, L3, and L4, and two transversals, which are M and M dash. Then the lengths of the corresponding segments, he means AB, A dash, B dash, BC, B dash, C dash, CD, C dash, D dash, on the transversals are proportion. That means that if L1 is parallel to L2, is parallel to L3, is parallel to L4, and M dash are two transversals, then AB over A dash, B dash equals BC over B dash, C dash equals CD over C dash, C dash, D dash equals AC over A dash, C dash, and so on. For example, in the figure opposite, AB line segment is parallel to CD line segment, parallel to EF line segment, parallel to XY line segment. AC equals 28 centimeters, CE equals 20 centimeters, DF equals 15 centimeters, FY equals 33 centimeters. Find the length of each of BD and EX. BD and EX. So the solution is, since AB is parallel to CD, parallel to EF, parallel to XY, therefore AC over BD equals CE over DF equals EX over FY. By substitution, 28 over BD equals 20 over 15 equals EX over 33. So, cross multiplication, we can find the length of BD. 28 times 15 over 20, the value is 21 centimeters. And to get EX, we multiply 20 times 33 divided 15. The answer is 44 centimeters. Talis special theorem. Since L1 parallel to L2, parallel to L3, parallel to L4, as we see in this figure, the three straight lines are parallel, and M and M dash are two transversals. Since also that AB equals BC equals CD, therefore A dash B dash equals B dash C dash equals C dash D dash. For example, in the figure opposite, find the numerical value of x and y. The solution: since AB is parallel to CD, parallel to EF, since AC equals CE, since AC equals CE, therefore 2x minus 3 equals x plus 2. Again, 2x minus 3 equals x plus 2. Why AC equals CE? Because BD equals DF. So, since AB is parallel to CD, parallel to EF, and since BD equals DF, therefore AC equals CE. So, by substitution, 2x minus 3 equals x plus 2. So, we can get the value of x, which is 5. So, since BD equals DF, therefore, y plus 3 equals x plus 1, and x is 5, so it's 5 plus 1. So, the value is 6 minus 3 equals 3. So, we find the value of x and y. The homework: try to solve these two questions at home. Thank you.